As MCP adoption grows inside your organization, you hit the governance wall pretty fast. Teams are spinning up MCP servers on their own, server URLs get shared in Slack threads, and nobody knows which servers are actually approved, who should have access to which servers, or who's responsible when something breaks. So here's what it looks like when that's solved. This is Bob. He's in finance. When he opens the registry, he sees Stripe, PayPal, and a handful of shared tools. Now here's Alice in engineering. Same registry, same endpoint, but a completely different catalog. Playwright, AWS docs, and other infrastructure tools. It's the same registry, but with different views. So let me show you how we got here. Stacklok Enterprise solves the MCP governance and discovery problems with the registry server, which is also part of our open source ToolHive platform. It lets platform teams build a curated catalog with claims-based authorization, so each user sees only the tools their role allows. The registry server runs in Kubernetes. In my cluster, I've already installed some prerequisites, including our operator, so I can manage custom resources like MCP servers, virtual MCP gateways, and the registry server itself. To deploy the registry, I've got a manifest here that creates an MCP registry resource. It starts with a source. This one points at a Git repository, specifically to our curated catalog of MCP servers. The registry will pull catalog data from that repo and sync it every 15 minutes. The data format is fully documented, so you can build out your own custom catalog with configuration defaults baked in to make it easy for users to not only find, but also run your approved servers. Then there's a registry definition that references that source. Think of sources as where does catalog data come from, and registries as which sources do I aggregate together. That separation lets you mix and match sources across multiple virtual registries with different access policies. And lastly, we have our database config. The registry needs a Postgres database to store the catalog data. In this demo environment, I'm running Cloud Native PG inside the cluster, but it could be a managed service like Amazon RDS, Azure Database, whatever you prefer. When I create the MCP registry resource, the operator handles all the setup. It provisioned the deployment, initialized the database, and created a standard Kubernetes service that can be exposed outside the cluster using any ingress or gateway API controller. And it's also already performed the first sync. We have over 100 MCP servers already populated into our registry. Looking at this from our Cloud UI web interface, users can now browse these servers and see all of the details they need to connect them to a client. Of course, our users don't really need all 100 plus MCP servers to do their jobs. So the first adjustment we can make is to add a filter and narrow down to just a handful of servers that we're actually interested in. The registry server can also pull from multiple sources and different types of sources at once. Here I've updated the config to add two more alongside the Git source. The first is the public community MCP registry. The Stacklok registry server is fully compatible with the official MCP registry API spec. Now, we definitely want to filter this one. The public registry has thousands of servers in it, and you definitely don't want all of them flooding your enterprise catalog. So I've included just a few entries, Figma, GitLab, and Postman, and this source will sync hourly. And last is a Kubernetes discovery source. This one's simple. It watches the cluster for MCP servers, remote MCP proxies, and virtual MCP server gateway resources that have been configured for registry discovery. So I'll apply the updated registry config, and refreshing our UI, we now see our filtered catalog with those three sources, the community registry entries, our Kubernetes resources, and our Git-based repository, all aggregated together. For the Kubernetes source, servers opt in using annotations. I've got a simple MCP server manifest here. It's running a Kubernetes MCP server we call MCP. The key annotation here is the registry export flag. That tells the registry, include me. The other annotations supply the metadata to populate the catalog entry. And as soon as that MCP resource is created, it shows up here in the registry. So now we've got 3 source types feeding one registry: a Git repo for curated catalog entries, the upstream MCP registry for vetted third-party tools, and live Kubernetes discovery for in-cluster servers and gateways. And all these are syncing automatically. But right now, any user sees the full list. And of course, we know that's not how real organizations work. Engineering doesn't need to see Stripe and PayPal. Finance doesn't need infrastructure or development tools. And that's where claims-based authorization comes in. Let's update the registry config one more time. Here, I've broken that Git source into 3 different source definitions. The shared source includes tools like Notion and Time that everyone needs, and its claims field matches the everyone group. So any authenticated user will see these servers in the catalog. The engineering source includes some development tools like Playwright, the AWS documentation, and the file system server. Only users whose identity token includes the engineering group will see these tools. And the finance source includes Stripe and PayPal scoped to the finance group. And critically, I've switched the auth mode from anonymous to OAuth, pointing at a Keycloak instance to validate user tokens. In production, this could be Okta or Entra ID, whatever identity provider your organization is already using. Now you might notice I didn't add a source-wide claim to the Kubernetes source. For those servers, claims work the same way, but through a granular resource-level annotation. Back on the MCP server, I'll add an authz claims annotation for the engineering group. I'll apply these latest configs. And we can see this in action through the Cloud UI, which is also configured to log in using Keycloak. The demo user I'm currently logged in as is the admin. The full catalog is visible. Let's log out and instead log in as Alice. Alice is in the engineering group, and so she sees the Playwright and AWS tools that we filtered in from the Git catalog, and the infrastructure tools and gateway running inside the cluster, along with those shared tools. But no Stripe or PayPal. And importantly, it's not just hidden from the UI view. The access controls are applied at the registry itself, so any AI agent working on Alice's behalf connecting to the registry API cannot discover these tools. Now let's log in as Bob. Bob's a power user working on some agent workflows for finance. So he sees the Stripe and PayPal tools that are scoped to the finance group, plus those shared tools, and the finance gateway with more internal systems behind it. But there are no infrastructure tools cluttering up his interface, just the tools his role requires. So we have 3 users and 3 different catalog views, but just one registry. A platform team doesn't have to stand up 3 separate servers just to make this work. So that's the Stacklok Enterprise Registry Server. With a single deployment, authenticated users get a personalized catalog based on their identity with multiple sources aggregated together: Git repositories, Kubernetes resources, an upstream MCP registry, all synced and aggregated automatically. And that's the foundation of enterprise governance for MCP. Learn more about the Stacklok Enterprise platform at stacklok.com, or get started with the open source ToolHive community project and join the discussion on Discord. Thanks for watching.